Okay, let's be honest for a second. If you're trying to keep up with AI right now, wow, it feels like you're just standing under a fire hose of information, doesn't it?
Oh, absolutely. Every single day. It's like new models, new research, benchmarks changing.
He's just overwhelming. How do you even know what's actually important?
It's a real challenge. Just the sheer volume, the pace, it's incredible. And figuring out, which bits really matter, which things signal a real shift,
Yeah.
that's the tough part.
Exactly. And that's really why we do these deep dives. We've sifted through a whole stack of the latest, most interesting stuff we could find. Think of it as today's digest of what's buzzing
Mm.
and tried to pull out the key things, the stuff we think you really need to know about right now.
Yeah, our mission here is basically to cut through some of that noise together. We're going to look at some, honestly, pretty fascinating questions about what AI is really doing. Get practical with updates on models like Gemini and Claude, see how they're actually performing, peek into some new tech for efficiency, and even touch on some interesting industry moves.
So yeah, today we're going to unpack this really thought-provoking idea from some recent research.
Mm.
Is AI genuinely thinking, or is it just incredibly good at, faking it?
The illusion of thinking.
Yeah, then we'll dive into the latest numbers and the user feedback for Google's Gemini 2.5 Pro, see what's actually happening there.
Oh, yeah.
We'll look at how Anthropic is boosting Claude, especially for coding and handling big documents.
That's been getting some attention.
Definitely. And then some cool tech trying to make models faster and leaner sparse transformers. Plus, we'll quickly touch on something called mixture of transformers and an interesting hire over at Morph Labs.
Sounds like a packed agenda, but yeah, all pretty important stuff for staying up to speed. Let's jump into that first one, the illusion of thinking. It really does make you stop and, well, think it.
It does, because sometimes you watch these models tackle a really complex prompt, and it feels like they're figuring it out step by step, like genuine thought.
Exactly. But is that what's really going on? So this research, basically, they put these state-of-the-art models through their paces on tasks that need sequential reasoning, planning, following rules strictly.
What kind of tasks?
Classic puzzles, the kind that really test that step-by-step logic. Right. Tower of Hanoi, moving the discs
Oh,
correctly.
yeah, I remember that one. Tricky.
Right. Or checker jumping, where you have to swap positions with specific moves. And blocks world stacking blocks according to rules. These aren't just trivia. They demand like a real process.
Okay, so they tested them on these logic puzzles. What did they find?
Well, this is where it gets really interesting, kind of counterintuitive even. They found that at low complexity levels,
Uh-huh.
the models that didn't have explicit thinking steps,
Mm-hmm.
they weren't writing out their reasoning.
Right, no scratch pad.
Yeah. Those models were sometimes more accurate and even faster.
Wait, really? Less thinking made them better on simple stuff?
Sort of seems that way, yeah.
Yeah.
It's the opposite of what you might expect, right? You'd think thinking aloud would always help.
Totally.
But then, as the complexity increased, the models with the thinking tokens, they did start to do better than the non-thinking ones,
Okay, that makes more sense.
but only up to a point.
Uh-oh. What happened then?
This is the really crucial bit. They hit what the paper calls a collapse point.
A collapse point.
Yeah. Beyond a certain threshold of problem difficulty, all the reasoning models they tested didn't matter, the architecture. Thinking tokens or not, just completely failed. Accuracy plummeted, like down to near zero.
Whoa. Completely failed. Just stopped working.
Pretty much. It highlights this potential fundamental limit.
Hmm.
But maybe the weirdest finding was how they failed. As the problems got harder and they got closer to this collapse point,
Yeah.
the models actually reduced their use of thinking tokens. Even though they had the compute budget, they could have generated more steps, they just didn't.
They started thinking less when things got tougher. That's bizarre. That's not how humans tackle hard problems.
Exactly.
So what does all this suggest? Good at simple stuff, better with thinking steps for a bit, then this sudden cliff they fall off and they even stop trying to think as hard right before they fail. What's going on?
Well, the researchers argue this pattern suggests that current models aren't really scaling their reasoning ability robustly with difficulty, not in the way genuine reasoning might. It seriously makes you question. Are they truly understanding the rules, the puzzle state, planning ahead? Or are they basically just doing incredibly sophisticated pattern matching? Matching the input, the intermediate steps, to vast amounts of data they've seen, but without real understanding.
And that pattern matching, While super powerful for lots of things, maybe it just breaks down catastrophically when the pattern gets too complex, too novel, too many steps removed from what it saw in training.
Precisely. That collapse point really seems to hint at that kind of limitation.
It's a really important distinction, isn't it? Moving from AI's thinking to AI looks like it's thinking because it's amazing at patterns. Huge implications there.
Massive implications for where we can actually trust and deploy these systems reliably.
Absolutely. And that kind of fundamental insight is a great lens for looking at all the practical updates we see constantly. So let's shift from that more theoretical idea to the front lines. Google's Gemini 2.5 Pro, the 0605 version specifically.
Right. This update's definitely been making some noise, especially on the benchmarks. It's apparently leading in categories like science, scoring, what was it, 86.4%? Pretty impressive.
Yeah, and putting up really strong numbers in reasoning and knowledge and coding, too. They specifically claimed 86.2% on the AIDER Polyglot benchmark for code generation. That's a tough one.
And it even topped the Chatbot Arena web dev ranking for a bit, right? Overtaking Claude Opus 4 with a score around 1443.
Those are the headlines, the leaderboard stuff. But when you dig into the user feedback from the sources, the actual experience seems a bit more, well, varied.
Yeah, the real-world picture is often fuzzier, isn't it?
Totally. So despite those high coding scores, some users found it really struggled with complex tasks. One person was pretty blunt, said it was absolutely dog trying to simulate a 3D solar system.
Absolutely, dog. Wow. You can feel the pain there.
Right. Compared it really unfavorably to other models for that specific task. And others reported stability issues, particularly with the Flash version, getting stuck in infinite loops when asked for structured responses.
Oof, infinite loops. Nightmare fuel. Just repeating the same text over and over.
Yeah, exactly. And then there's the practical stuff like API rate limits. People are reporting caps around 100 messages per 24 hours.
100? That's not a lot if you're trying to automate anything.
Right. Users are saying it basically makes it useless for building scripts or integrating it properly into dev workflows that need more interaction.
And that's compounded by another observation, right? That the API sometimes doesn't even seem to have the same capabilities as the web interface.
Yeah, exactly. The API lags behind, which is super frustrating if you're a developer relying on it.
Definitely.
And just a general gripe, not just about Gemini, but across the board, is how confusing the versioning and naming can be. It makes it hard to compare apples to apples or even know what version you're using sometimes.
That ties into that whole discussion around the leaderboard illusion, doesn't it?
Explain that a bit.
Well, the concern that maybe companies put their absolute best, perhaps specially tuned, maybe not even widely released, private versions up against public benchmarks.
So they're showcasing the peak performance, which might not be what you or I get access to day to day.
Exactly. It could skew perceptions of how reliable or capable the generally available model actually is. It's just something to keep in the back of your mind when you see those shiny benchmark scores.
That's a really good point. I always got to check the real-world reports, too. Okay, speaking of other models in real-world use, let's pivot to Anthropic. They've had some interesting updates for Claude, particularly around coding and dealing with big documents.
Yeah, a big practical one is that Claude Code, which seemed maybe tied to the higher tiers before, is now available on the Pro subscription level.
And users seem pretty happy about it. We saw reports of people being seriously impressed, calling it a game changer for their coding work.
That's great feedback. And they mentioned pretty generous usage too, right? Like being able to code for hours.
Yeah, someone mentioned like 4 or 5 hours straight before hitting limits, which suggests the Pro plan quotas for this are pretty reasonable for actual coding sessions.
Okay, but here's the slightly weird part. Users on the more expensive tiers, Teams and Enterprise, were saying they don't have Claude Code available yet, which feels backward.
Yeah, that is odd. You'd expect the pricier plans to get the best features first. Maybe it's just a rollout timing thing they need to sort out.
Maybe. Also on the Claude front, though, they massively expanded their projects feature, like increase the amount of content you can give it by 10 times.
Yeah, 10 times. That's huge if you're trying to feed it a lot of context. How does that even work? Does it just have a giant context window now?
Not quite. And this is the key technical bit. When you upload stuff that goes beyond the old limit, Claude automatically switches into a retrieval augmented generation mode, RAG.
Okay, RAG. Break that down simply.
So instead of trying to cram every single word into its immediate memory, which gets impossible really fast,
Right.
it uses the uploaded documents like a searchable database. When you ask a question, it first intelligently searches through those documents to find the most relevant pieces of information.
Got it.
And then uses that retrieved info plus your question to generate the answer.
Ah, okay. So it can effectively access and use way more information without needing an impossibly huge context window.
Exactly. It makes it much, much better for handling large documents, big data sets. Think like analyzing massive technical manuals, semiconductor data sheets, long reports, stuff that was really hard before. It brings it closer to what, say, ChatGPT can do with its RAG features.
That ERG capability is a really big practical improvement. Now, here's another kind of funny observation someone shared about Claude's projects feature related to time estimates.
Oh, yeah?
So give it a task, and Claude might estimate the time like a human developer would, saying, this project will take about 5 higher days.
Okay. Sounds reasonable.
But then the same user reported that Claude actually delivered the finished code in under an hour.
Wait, what? 5 to 8 days estimated, but done in less than an hour.
Right. That's a massive difference.
That's hilarious. What does that even mean?
Well, it strongly suggests its time estimates aren't based on its own processing speed at all. It's probably just learned those kinds of phrases 5, 8 days from all the human text it was trained on, like project plans or emails maybe.
So it's mimicking how humans talk about time, not reflecting how long it actually takes the AI to do the task.
Exactly. It's a fascinating little quirk, and it led to a pretty smart prompting tip someone shared. Just tell Claude explicitly to avoid giving timeframes or estimates. Just focus purely on the actionable steps needed to implement the solution.
Cut out the human-like filler and get straight to the point. Makes sense. Smart.
Okay, so we've hit on AI thinking, practical model performance. Let's switch gears slightly to efficiency, making these giant models actually usable without needing a supercomputer. Nimble Edge and their work on sparse transformers caught our eye here.
Yeah, efficiency is always a huge challenge. These models are beasts in terms of compute and memory, both for training and for inference, just getting answers out.
Right, and Nimble Edge is focused on that inference part, using techniques based on sparse transformers.
And the promise is pretty appealing. The sources mention claims like 2x faster LLM inference with 30% less memory.
That sounds great. Did they have specific numbers?
Yeah, they shared some benchmarks using Llama 3.23b models, showed things like 1.51 times lower time to first token.
So it starts talking faster.
Right. And about 1.78 times faster overall throughput, more words per second, and used about 26.4% less memory compared to standard ways of running it.
Those are definitely significant gains if they hold up across different models and tasks. What's the basic idea behind sparsity?
Okay, so technically they mentioned using things like fused operator kernels and structured contextual sparsity. But the core idea of sparsity is simple. In these huge neural networks, not every single neuron or connection is actually needed for every single calculation.
Right, some parts are probably irrelevant for certain inputs.
Exactly. So if you can intelligently figure out which parts are not needed for a specific input and just skip them or make them inactive,
You save computation and maybe memory.
that's the goal. Faster processing, less memory footprint. But as the discussions pointed out, there are still some big questions users have.
Like what? What are people asking?
So the number one question is always, does making it sparse hurt the quality of the output? Faster is no good if the answers become dumber or less accurate.
Crucial point.
Yeah.
What else?
How does it stack up against other efficiency tricks, like quantization? Quantization reduces the precision of the numbers, which also saves memory and speeds things up. Do you use sparsity instead of quantization, or with it?
Yeah.
How do they compare?
Good question. And practicality.
Yeah, huge one. How easy is it to actually use this? Is it plug and play? Can developers easily apply this nimble edge approach to lots of different models, especially popular formats like GGUF that people use to run models on their own computers, their own GPUs?
Right. Is it a niche thing for specific models or something that could become widely adopted? Those practical questions are key.
Definitely determines if it's a cool research demo or a tool a lot of people can actually benefit from.
Okay, and just briefly, a couple of other related things popped up in the digest. Mention of something called mixture of transformers, or MOTI, and heterogeneous training.
Right. MOTI sounds like maybe an evolution of mixture of experts, or MOE models. MOE routes different inputs to different specialized subnetworks experts. So a mixture of transformers might apply a similar idea within the transformer architecture itself, maybe activating only certain layers or heads depending on the task or input. Again, aiming for efficiency by not using the whole massive model all the time.
More ways to try and be smarter about computation and heterogeneous training.
That likely refers to training models across different types of hardware simultaneously, maybe GPUs, TPUs, other accelerators, which could be really important for training these absolutely enormous models more cost effectively or faster. It's all about optimizing that whole pipeline.
Makes sense. And one last quick note on the people side of things. Morph Labs hired Christian Segedy.
Yeah, that's an interesting move. Segady's a pretty big name in AI research. He was involved in the famous Inception architecture for computer vision,
Right.
and he's done important work on things like adversarial examples, how to fool models and model interpretability, trying to understand why models make the decisions they do.
So bringing someone like that on board, what does that signal for Morph Labs?
Well, hiring someone with that deep background in core neural network design, but also safety and understanding, it could suggest they're focusing on building not just powerful models, but maybe ones that are more robust, more trustworthy, or easier to analyze. It definitely shows the competition for top research talent is still really intense.
Yeah, another sign of how companies are trying to get an edge, whether it's new tech, better efficiency, or key people.
Exactly. It all fits together.
So, wow, we've really covered a lot of ground today, haven't we? From that really deep, fundamental question about AI thinking and seeing where current models might hit a wall.
Yeah, that collapse point research is fascinating. And then down to the nitty-gritty of Gemini's benchmark scores versus the absolutely dog user experiences and API limits.
Right. And Claude's stepping up its coding game and handling huge documents with RAG, even if its time estimates are optimistic.
Hilariously optimistic. And then looking at the tech trying to make it all run better, like sparse transformers from Nimble Edge and these other ideas like MO, plus the people moving around.
It really is all connected. And all these developments, from how these models might be faking thought to how they perform on your coding task today or handle that giant PDF you feed them, it directly impacts how you can understand and use AI effectively.
And it kind of brings us back full circle, that illusion of thinking idea, doesn't it? Considering the amazing progress, but also these apparent limits when things get really complex.
Yeah. It makes you wonder, what does it really take for AI to go beyond just being an incredibly sophisticated pattern matcher, to get to something we might genuinely call understanding or robust reasoning?
And what kinds of truly complex, maybe world-changing applications are still waiting on the other side of that gap, whatever it might be?
That's the big question, isn't it? It's what keeps this field so exciting and, frankly, unpredictable.
Absolutely. The capabilities today are already mind-blowing, but figuring out their true nature, their limits, that's crucial for building what comes next.
It's a wild ride. Definitely keep exploring, keep asking questions, and keep diving deep with us.